Right, so we're going to start with a revision question on exponential functions. So let's do a real world type example. So let's think about a casting is removed from a furnace at, let's go for 300 degrees Celsius, and cools according to, and we'll make up a formula. So temperature equals T naught e to the power of negative 0.12 T. Okay, so this is a rule, this is a law that governs how it cools, and it's an exponential, the E in it, and it's an exponential decay because of the negative. So it's going to be start big, hot, and cool down. Okay, and normally when you get these, they'll tell you what the various letters stand for. So T is the temperature at time little t. Okay, so little t is going to be the time, and big T is the temperature, how the temperature varies. So big T changes over time. T naught is the initial temperature, and little t is the time in minutes. Okay, so we're going to work in minutes in this case. And the fact that I've given this in degrees Celsius means it's probably a fairly safe assumption, although a good question would tell you that the temperatures are going to be measured in degrees Celsius. Though you'd expect that information to be given formally in an exam. Okay, so let's do a few things with this. So let's start with sketch the graph of this relationship. Okay, so this is the sort of question you could well end up having to deal with. Okay, when you're asked to sketch a graph in an exam or a test, there's marks for quite specific things. Okay, so this is one of the places where you can grab some marks, even if you really don't have much of an idea of what's going on. Okay, so whenever you're asked to sketch a graph, you'll find that there's going to be marks for label on the axes. Okay, so even if you don't really know what the curve looks like, what are the two things that you're measuring? Which one goes on which axis? Yep, there's often a mark for getting that right. So what do we think in this case? What things are going to be on the axis? Time and temperature. Awesome, Harrison. Which one's which? Temperature's the y-axis. Okay, so this is going to be temperature, and you normally put units, degrees Celsius, and this one's going to be time in minutes. Yep. 1 mark out of 3 for this question, so well done. Okay, so do I have to know anything much about what a curve looks like for that? No. Okay, so that's actually worth a mark, and being able to do that sort of thing in an exam rather than just look at the question and go, crap, it's a crap, I just said crap on video. I shouldn't have said that. Okay, so, Amori's taken notice, which bit to edit out now. Okay, so when when you come to do an exam and get those sort of marks, you need 24 marks. There's one of them right there. Yep. Okay, the second mark is usually for intercepts. So any points or vertices, if they have them. So points that matter, points that are sort of important. So reading that question there, what's the one point I can stick on here nice and easy to start with? 300. Okay, so where does the 300 go? On the y-axis. So if I'm up here somewhere at 300, okay, and we know it's there because it says it's at the start. It's where it starts to cool, so t equals 0, y equals 300. So we've got that point. There's another mark. We haven't had to do anything too sophisticated yet. We've just labelled the axis and put the things on. And I see Harrison's explaining to Zane what it looks like. It looked pretty good. No, the negative 0.12 isn't a point. That determines the slope effectively. Okay? So what's the shape going to look like? Everybody draw it in the air. 1, 2, 3, go. We've got a circle in the back. We've got, what else? Oh, Shane looks pretty good. Fitz look pretty good. Yep. Okay, so it's going to look like that. Yeah, it's a curve. It's curving down and getting flatter and flatter. Yep. That's your 3 marks. Done. Yeah, that's what it means by sketch. If you wanted to put another point on, you could. You could just make up a number. With t equals 100, what's happening, for example, you could put it on. But that's the essence of what they want in a sketch the curve type question. Okay? Label the axes, put on any intercepts, and then the last mark is for the general shape. Okay? So if you see a question tomorrow that asks you to draw a curve of something, yeah, it's doable. Yes. Yeah, I mean, you could write a fancy title about castings from furnaces and things. In this case, it sort of goes with the question, so it's kind of important. Yeah, if you're doing a report or something, absolutely. Whenever you've got a graph, you should definitely have a title with it. Not going to be marks from that in a maths exam, but there will be in anything you do with the maths exam. Okay, and you can put the equation on. So this is the equation: t equals 300 e to the minus 0.12t. That would be that's the equation of the curve. The sun moved. Oh, sorry. Not used to being having to teach in a pen then. It's not my style. Okay, so now that we've got that sort of thing sorted out, we can answer questions like how hot, no, going to be an engineer here. Hot is a rubbishy word. What temperature? Hot is a measure of heat, which is measured in joules. This is temperature, which is measured in degrees. So what temperature would you expect the casting to be after, say, 10 minutes? Okay, how are we going to go about doing this? How are we going to, oops, stay inside the line. I'll go this way. How are we going to figure out what the temperature is going to be after 10 minutes? Which t? Small t? Yep. Okay, so what we're hearing here, which is perfectly correct, is that this 10 minutes is little t. So we're going to substitute where there's a little t, we're going to write in a 10, and that should give us the answer. So t is going to equal 300 e to the minus 0.12 times 10. Stick that in brackets if you're going to do it on your calculator, because your calculator will want to do the exponent before it does the times because of bed mass. So if you're going to do it on your calculator, we'll which I assume you are, you're going to need give the calculator a bit of a hand. I haven't brought my calculator with me, so I'm going to rely on at least 2 or 3 people around the room doing it. Or if you're at home watching on the video, you can do it at home yourself as well. And then figuring out the answer here. So who's got an answer? Say again? 90.36 units for that? Anybody else? Oh, it's Reggie returning my calculator. You can keep it, Reggie. You hang on to it, then you just got to yell out the answers from the back. Anybody else do the same and get the same? Yep, and get a couple of nods. So we're all happy with that? Yep. Okay. Simple enough. Okay, let's do after how long will the casting be at 40 degrees Celsius? Okay, so how long do you have to leave it before it comes down to 40 degrees? Okay, so following Chris's suggestion before, where we looked at the number we were given and we gave it a letter so we knew what we could substitute into the equation, this 40 degrees is going to be what? TO. TO is the initial time. So TO we already have is the 300. So it's not TO. So the big T. Okay, so the big T is now going to be 40 degrees. And what we're trying to find out is, which letter are we trying to get the answer for? Little t, because the how long, isn't it? So it's a question, it's a time question. So we're trying to find little t. Yep, so we know big T, and we're trying to find little t. So how do we go about finding little t if we're told this equation? Rearrange, awesome, that's the answer. That's the answer to everything, rearrange, yep. So what we've got to do is take the equation that we had and rearrange it to get little t by itself. Okay, so if you look at that, there's a 300 we've got to deal with, there's an e we've got to deal with, and there's a negative 0.12 we've got to deal with. So which bit do you want to deal with first? The 300, and how are you going to deal with the 300? Divide by 300? Yep, so t divided by 300 is e to the minus 0.12t. Okay, so I've just said that 300 is attached by multiplication. Yep, so it's effectively a multiplication in there. And we've undone that by dividing both sides by 300. And I don't mind what stuff you put beside it or how you cross it out or whatever, as long as you end up with another line that tells me that sort of equation. That's cool. Awesome, so we've dealt with the 300, which leaves us an e and the negative 0.12. Which one do you want to deal with next? Okay, Ricky, do you want a bit of paper? It's a pretty exciting bit of paper. It's got your next assignment on it. The e, and how are you going to deal with an e? Log the other side. Okay, so e to undo an e is a natural log. So we end up with natural log of this side. Yep, so just said we want to remove the e. To undo an e is a natural log. So we need the natural log of the other side as well. Brilliant. Say again, Rich? Yep, divide by, exactly. Because again, we've now got, this is negative 0.12 times t. So we want to undo that times, which is a divide. So we end up with little t equals natural log of t over 300 divided by negative 0.12. Okay, so we've rearranged the equation, so we've now got little t equals, which is great because that's what we wanted. So now I can substitute my number in because I know what big T is, it's going to be 40. So I've got little t equals log, natural log, 40 over 300 divided by negative 0.12. And now that you've got something that's only got numbers and symbols that are on your calculator, you should be able to reach for the calculator and start hammering buttons and come up with, drum roll, 16.8 units for that, Kieran. Thank you. 16.8 minutes. Okay? That's a pretty standard sort of thing, which you should be able to do at some stage. Okay, so you're going to see something like that in the tests tomorrow. Any questions on that before we move on to the next thing? Shane? Natural log and E. Natural log is log base E. Okay, so, yeah, Michael. Hand it, mate. Yep. Okay, so let's deal with all this. That's a really good question. I'm going to write out this bit of the questions. We've all got that down. And we're going to, no, Michael hasn't, he just walked in. Can I use this bit of space in the corner here? Is it still going to survive? Okay, so what do you got? What buttons you got on your calculator, Shane? LOG, yep. LN. Okay, now the E is actually E. Is it just E or is it E power of X? Just E on your calculator. Are those two on the same button, but one of them is a shift function? E squared. E to the power of X. Yep. Okay, so those two are on the same button, aren't they? You've got your natural log and then E to the power of X is above it. And E. Yep. What goes with your log button? 10 to the power of X. Excellent. Okay, brilliant. Okay. Do you actually know what a log is? Do you know what log actually does? So let me explain what log does. Some of you have heard this explanation before, so if you have, don't spoil the punchline. Okay, so the question is, how many 2s are there in 8? 4? Yep, so I'm asking the question, how many 2s are there in 8? Sorry, Michael, I'm going to rub this out. You have to get it from someone else. I need some more board space. Okay, so the question simply is, how many 2s in 8? Okay, and you've told me the answer is 4. Yep, so what you're thinking this. 2 plus 2 plus 2 plus 2 equals 8. That's how you get 4 2s to make up 8, isn't it? Okay, so because in maths we get a bit lazy sometimes, if I'd asked you how many 2s were in 100 and you'd gone 50, I'd have died of boredom before I wrote 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 100. So we've got a shorter way of writing it. So the short way of writing it is 2 times 4 equals 8. Yep. And then when I'm asking you this question, going backwards, what I'm asking you is, if I start with 8 and I want to break it up into 2s, how many are there? And that's the question you asked when I said how many 2s are there in 8. Yep. So we think about repeated addition, which we call multiplication, and we've got a way of undoing that, which we call division. Yep. Happy with that? That's all stuff you're familiar with. The only problem is that you're wrong. There's not 4 2s and 8 at all. There's only 3. Yep. It only takes 3 2s to make up to 8. You don't need 4 of them at all. It's only 3 of them. And again, because we have this idea of something being repeated, we just have a shorthand way of writing it. And this we just write as that. Yep? And if, when I ask you the question, how many 2s are there in 8, I want you to answer it this way and not this way. We're exactly the same as we did here. We need to have 8 broken up into 2s. Okay? And the way you write that, if you want this answer, is you go yeah, 8 broken up into 2s. How many are there? Okay? And that's what log is doing. Log's just saying to you, how many of these are there in that if you do it by multiplication? That's what a log is doing. Okay? So the key question when you use a log is, what base is it? So this is, I want to know how many 2s there were in 8. Okay? So try this on your calculator. If you just use your log button on your calculator, just your straight log button, and you say to your calculator, what is the log of 1,000? It will tell you 3. So what's the base it's using? 10, because it's 10 times 10 times 10 is 1,000. Yeah? So when you push the log button on your calculator, it's actually doing log base 10. It's answering the question, how many 10s are there in this thing? Okay, so that's what the log button is doing. If you push the natural log button, the LN, then what it's actually doing, it's actually asking you how many E's are in this thing. Okay, E is just a number. Yep, it's just a number. It's a number that comes up a lot in nature. All these sort of decay curves and growth curves are governed by E. Yeah? So your calculator's got 2 ways of asking the question, how many are there? You can answer how many 10s, because we do everything base 10, the whole metric system is base 10, and it can answer the how many E's are the question, because of all these exponential growth and decay curves. Okay? Some of the new calculators have actually got a log base N button. Has anyone got one of those? Harrison's got one. Yep. So that way, that can answer the question. You could ask your calculator this question directly. You could type in the log button and the 2 and the 8 and get 3. But most calculators don't have that facility. You either can choose how many 10s are there or how many E's are there. You've only got those 2 choices. That was a really long-winded way of answering your question, Shane. Does it make any sense at all? No. No. Okay. Does this make sense, what your log's doing? On this one on your calculator, if you want to work out that on your calculator, you can't directly. You have to understand the laws of logs and play around with it and do it, change it into base 10. Okay? So your calculator doesn't have the capacity to do that directly. Yeah? Yeah? But for the E stuff, so here, whenever you've got an E, it undoes it with a natural log. Okay? So in your rearrangement, natural log. And all of these exponential growth and decay stuff is going to be natural logs. So E is the answer to all of those sort of things.